Good afternoon everyone. So today we'll discuss about the third lab program, that is design, develop and implement an YAC-RDC program to construct the predictive parsing, that is an predictive parsing. It is same as an LL1 grammar, both are same, parsing table for the grammar. So this is the given grammar and we need to parse this particular string by using a predictive parsing technique. So all of you know that how the predictive parsing technique will work. So already you have taken a test on this also. So predictive parsing technique works based on these following steps. First, for a given grammar, it will try to remove the left recursion. Then it will do the left factoring. Then it computes the first and follow of non-terminals, that is which are at the head of the production A and B. And then compute the follow of A and B. Then it construct the predictive parsing table. Then uses that predictive parsing table in order to parse the given input, that is A, B, B, A. So for this particular grammar, first step is remove the left recursion. But here there is no left recursion. And do the left factoring. Here no concept of left factoring for this particular grammar. So what we will do, we will start with the third step, that is we will first find out the first of AB, then we will find out the follow of the AB, then we will construct the predictive parsing table, then using that table we will parse the given input string by using a stack concept. So first two steps anyhow you are not applying here, we will start from the third step. Now I'll tell you what is this first and the follow. So all of you know that how to compute the first of the A. So first of the A, in this case only beginning of the body of the production you are having a terminal. So first of the A will be an A only. You cannot have anything else. And what is first of B? First of the B is nothing but the B only and epsilon. So here instead of writing the epsilon, we have considered it as a yet. That's it. There is no difference between the epsilon and the yet in this program. And one more thing, remember in this particular program, this program is written only for this particular grammar. We are not at all considering anything else. Only keeping this particular grammar, the program is written. If you are giving different grammar, then this program will not work. Keep that in the mind. Okay. Then that is the first of the B is B and epsilon are the yet. First of the A is A. And what is the follow of the A? When I will come to the follow of the A, so here what is follow of an A? Are you having anywhere the A symbol in both the production? No. So but since it is a start symbol, what is a follow of the A? It is a dollar. Okay. Then what is the follow of the B? B you are having here, B you are having here. So what is follow of the B? There is a terminal A. So terminal A has to be written for the follow of the B. And one more B also you are having. But follow of this is nothing. Therefore I have to write follow of the B. What is follow of the B? It is again small a only. Therefore your follow of the B is A. So that I will explain you with the program. So these are the steps that need to be followed. Then predictive parser need to be constructed and you need to parse the input. So here let us start with the program. So there are some declarations are there. You go through those declarations. These are all the different functions what you are using in the program. That is first set in order to compute the first, follow set for computing the follow, and for constructing the parsing table we are using parsing table function, and for parsing we are for parsing the given string we are using parse input function, and if any error is there that will be handled with the error function. And here some of the declarations we are doing. So GRM grammar, it is two-dimensional array. Then first, whatever first of the non-terminal we are finding, that is stored in first, and whatever the follow of the non-terminal we are finding, that will be stored in follow set. Then this why we are storing it in some of the two-dimensional array, because for construction of the parsing table we need this first and the follow. That is the purpose, and we are using a stack. Why stack is used? For parsing at the last step. For parsing the given input we want this. Matched is also at the end, that is during the parsing. You remember that columns we have written, no? That is stack, matched, action, input buffer. So at the end during parsing we required this array, and input here also this particular variable is required for an last step, and this is also required for an last step of your parsing. So now first I will start with a main previous we had only the declaration section. Now I will come to the main program. So whatever I have written in the red color, it is for an tracing I have written, and whatever is there in the black color, it is your program. Okay, in the lab manual you can find this one, and it is available in my website also, that is Savita BIT CSE website. You go through Google site, not website, Google site, you will find out this manual. Okay, then come to the main program. So in the main program, just what we are doing here is we are printing what is that grammar. Same, A determine ABA, B determine BB and epsilon. So same grammar we are printing. Enter the number of the rules. Number of the rules are nothing but how many productions you are having. So number of the rules entered here is the 2, because you are having production for A, production for B. Rules are nothing but the how many non-terminals you are having. So only for the non-terminals we will have the production. So that's why. So value of the n is equal to and 2. Now enter the grammar and please enter the et instead of an epsilon. As I told you here this et will represent the epsilon. Et will represent the epsilon. Okay. Then for I is equal to 0 to n. What is my n value? It is 2. So what is I value? 0. So this for loop will work for 0 and 1. See here, it works for 0 and it works for 1. So I am scanf grm of I. So when I am using a string function, so whenever I will say grm of I, so what is grm of I initially? 0. So I am reading this 0. Means when I'll go to that declaration part, I have considered grm as a two-dimensional array, but here we are considering only grm of an I. So when you are reading any of the string, so it is grm of 0, it will understand implicitly that is nothing but grm of 0, 0, 0, 1, 0, 2, 0, 3, 0, 4, 0, 5. So till where it will go, that 0, till you will go to the next line. So remember this one, when you will be and typing these two production, so after you will type this A determine ABA, you go to the new line. Don't type the grammar in the same line. This will not work if you are typing the grammar in the same line. So you need to go for the next line. So then only this will be unconsidered. Otherwise you will get a wrong output. So remember this point properly. So both the production, whatever you are having for the A and B, it should be in the different line, and whatever you are typing for a B production, so again BB are epsilon, so they should be in the same line. Remember this point also. Don't type the in the or the epsilon in another line. Okay, this should be in the same line and all of this should be in the same line. So remember that particular point. So whenever it is grm of 0, it will implicitly consider that as a 0, 0, 0, 1, 0, 2, 0, 3. So till where it will consider that 0, 5, that is till you will enter the next line, it will go on consider that one. So what we are reading, that one, whatever we are reading A, that will stored in 0, 0. Then this minus symbol is stored in 0, 1. This greater than symbol is stored in 0, 2. Then A is stored in 0, 3, B is stored in 0, 4, and again A is stored in the 0, 5. So now once I will enter the next line, so this for loop will go to again for loop and I value will be incremented. Now grm of a 1. So GRM of an 1, implicitly it will consider it as a 1 0 1 1 1 2 1 3 1 4 1 5 till again you will enter the next line. This will consider that one. So what we are having for a production for the B, so B will be stored in 1 0 and minus symbol is 1 1 and greater than in 1 2 and B is 1 3 and capital B is 1 4, pipeline is 1 5 and X is in the 1 6. So that is what we are doing by using this scanf statement, and when it is a type string, that automatically GRM of an 0 is nothing but 0 1 0 2, it will consider like this, implicitly it will consider that one. So what we are doing in this particular statement, we are reading this, okay, means we are reading both the productions, this production and this. So this is only for the new line, don't get confusion here, it is a new line, okay, so it is a new line. So after that one I am calling the first function, then follow function, then parsing table, then parse the input. The 4 functions what I told, we are calling all these functions. Now I will move to an one by one functions. So that is, first I will check for an first function how it works. So whatever here it is there in this first function, the black color, it indicates that it is an, what this indicate? It indicates that it is a program, and whatever is there in the red color, that applies for both the first of A and first of B. Whatever is there in the red color, that represent for both first of A and first of B. Whatever is there in the blue color, that is for first of A, and whatever is there in the green color, that is for a first of the B. Okay, first of A, whatever I have written the tracing, it is for first of A, and green color whatever I have written, it is for a first of the B, and whatever is there in the red color, it is for both the first of A and for the first of the B. Okay, so we'll start here. So this is the given grammar, A determine this and B, this is the given grammar. Okay, already we are read this particular grammar. Now I'll start for a first function. Now enter the first set. So here first initially what we are displaying the statement is the first set is, so this is displayed common for both of them. Then I'll come to this one, I will be an 0 and the count will be an 0 and j will be equal to 3. Some of the declarations you are doing, I is 0, j is 3, count is equal to 0. So before that we will consider count and this one, something we are printing. What is that? Printf first of %c. What is this % of c I am considering? It is an GRM of I0. What is my I value? 0. What is GRM of 0 0? So GRM of an 0 0 is nothing but the A. So what I am printing, first of A, first of the A is equal to open parenthesis, okay. So this I am printing. So this is the output what you are getting. So whatever I have written in this particular line, this is the output what you are getting. First of the A is nothing but the A, and the first of the B is nothing but the B and epsilon, B and the epsilon. So first of the B in this production it is B, and in this production B determine epsilon is there. So what is first of B? First of the B also include the epsilon. So that is the first of the A, and this is the output I have written, final output. Now I am doing the tracing, okay, line by line. So what I have printed with this particular statement, I have printed first of A is equal to A. So that is over, okay. Only the left out thing is A I have to write, close parenthesis I have to write. What are the things I have to write for the first of A I have to write, close parenthesis I have to write. The rest of all till here I have already wrote here, okay. So that is print of this. Then I am taking count as a 0 and j is equal to 3. Now I will come to this while statement. In the while statement I am checking that is array has some element or not, okay. So what is my I value? 0, and what is j value? 3. So grammar of 0 3. What is grammar of the 0 3 you are having? It is small a. Grammar of the 0 3 is an small a. I am checking that whether it is a null or not. means in this array are we having any of the elements or not, that we are checking. So in this situation whether this A is not equal to null, yes, it is not equal to a null, so I'll enter into this. Now what I am checking during this particular if statement is I am checking whether it is a terminal or not. Not of a non-terminal means what? Terminal. Not of a non-terminal. This grammar of an ij is greater than 64, so capital A, and it is less than 91, capital Z. So it is not between A to Z, capital A to capital Z, not between capital A to the capital Z indicate what? It is a terminal. So not of a non-terminal. Not of a non-terminal is nothing but a terminal. So I am checking that. So whether the grammar of an 03 is a terminal or a non-terminal. So it is a terminal. So why it is a terminal? The 03 is nothing but a terminal. 03 is nothing but a small letter A. So it is a terminal. Therefore I'll enter into this particular if terminal. If terminal, then I'll enter into this. So here what I am doing, FST of I told you this is the array which is used for storing the first and the follow functions. FST is for first. What is I? 0. What is count? 0. So first of 0, 0 I am storing grammar of an 03. What is 03? Small letter A. So small letter A I am shifting it to the first of 0, 0. Then I am printing that same FST of 0, 0. What is FST of 0, 0? Which is nothing but the A. Now I am printing A. So now initially what I have printed, F first of A is equal to open parenthesis I have printed. Now what I am printing? A. So means till here is over. Only the next thing I need to include is this close parenthesis I need to include. So till A I have already printed. Only the thing I need to include for the output of the first of the A is this closing parenthesis. Okay, that we'll see. Now a count will be an incremented. Now the count will be equal to 1. So once the count will be an equal to the 1, then where we'll move, we'll come to this. Okay, count is equal to 1. I'll come to this for loop and look at this for loop. It is having the semicolon. So when we will have a semicolon for any of the for loop, that will continue till that condition, means the j value will be go on incremented till that condition will become a false. Until that is true, this j will be an incremented. So what is in this, what I am checking initially, the grammar of an 03. 03. What is grammar of 03? Small letter A is not equal to the pipeline. Yes, A is not equal to the pipeline. A is not equal to the pipeline. Yes, it is true. Then 03, grammar of 03 means small a is not equal to the null. Yes, that is also true. A is not equal to the null and A is not equal to the pipeline. Pipeline means why? Because for this production we have to means pipeline indicate what? Are we having any other production? We are checking. That's it. Okay, both are the true, then j will be an incremented. What is j value now? It was 3, now it is 4. Okay, when it is 4, now 0, 4. What is you are having in the 0, 4? So 0, 4 I am having a capital B. So now I am checking whether the capital B is a null. No. Then is the capital B is a null value? No. Then increment the j. J is now 5. J is now 5. So what is now, again I will come to the same for loop because it is having a semicolon. Till this condition will become false, I have to be here only. Now 0, 5. What is there in the 0, 5? 0, 5 is a small letter A here. 0, 5 is small letter A. So I will come to that. Then I am checking whether the small a is not equal to pipeline. Yes. It is not equal to pipeline, and small a is not equal to null. Yes, small a is not equal to null. So I am incrementing the j. So what is my j value now? J value is 6. Now again I will come to this one. So grammar of 06. What is the grammar of the 06 you are having? So 06 is actually the null value. So once I will finish this particular grammar, what will be stored? The null will be stored. So now when I will come to this one, this condition will become a false. So again I will not increment the j, I will come to this one. Again in this also what I am doing, I am incrementing the j value. Now the j is equal to and 7. So once the j will be equal to the 7, now I will go to this while loop. So while what is this 0 7 is not equal to null. What is my 0 7? 0 7 I am not at all having. So obviously what is 0 7? It will be a null only. So then again I will come here. So but now in this case it is equal to the null. So I will come out of the while loop. So I will come out of this while loop and I will print the close parenthesis. I will print the close parenthesis. So whenever we are printing the symbol, this backslash b is for just a space we are using, and what is we are finally printing? The close parenthesis. Now over now for the first of the a, here we have printed first of a is equal to open parenthesis. Here we have printed the a. Here we have printed the close. Now it's over. First of the a is over. So now again I will come back to the for loop. I value will be incremented by 1. So what is my I value now? It is 1. Is 1 is less than 2? N value is 2. Yes, 1 is less than 2. So now I will move for this. So 1 means what? 1 means it is nothing but I am moving for the second production. I am moving for the second production. That's why it is 1 now. Now I am printing first of the percentage C. What is I value? 1. What is GRM of 10? What is GRM of a 10? GRM of a 10 is a capital B. So I am printing this GRM of 10 is nothing but the B. So that is green color whatever now comes. So printf first of the B. So first of the B is equal to, so is equal to open parenthesis, open parenthesis. So with this particular sentence we are printing this one, first of the B is equal to. That means from here to the here it is over. Now what I have to print? B I have to print, and yet I have to print. What I have to print? I need to print the B and I need to print the A. Those two things I need to print now. Again I will consider the count is equal to 0, and again I will consider the J is equal to 3. Now again I am checking whether 1 0 is not equal to null. So what we are having in an 1 0? 1 3. J value is 3, no? What we are having in a 1 3? We are having a small b. So we are checking 1j. What is j value? 3. What is 1 value? Now it is 1. Now it is 1. So now I am checking 1 3 is not equal to the 1 3 is not equal to an null. Yes, B is not equal to null. So I will enter into this one. So again I am checking whether it is a terminal or not. Since small b is a terminal, so this condition will become not of a non-terminal, means it is a terminal. So I will enter into this one. So now I am saying that the 1 0, first of 1 0, that is this one, first of the 1 0 is equal to GRM of an 1 3. So what is 1 3? Small letter b. Therefore I am copying that one to here and I am printing that one. So I am print the b. So that means I have printed b. Now I have to print only the epsilon symbol. Okay. Anyhow, comma will be unprinted here only when I will come back to the next time. Okay. Now count will be incremented by 1. Okay, count will be incremented by 1. It is done for both. That's why it is in the red color. Now count is equal to and 1. Now I will come back to this one, this particular statement. Now GRM of an 1 3. It is small b. So whether small b is equal to the null pipeline? No. Means this is true. Not equal to the pipeline is true. And small b is not equal to the null. Both are true. Therefore I will increment the j value. Now what is my j value? That is 4, which is written in the green color now. Blue is over. Now I am tracing for a green color. So now j value is 4. Again I will come. What is 1 4? What is 1 4? We are having symbol 1 4 is a capital B. Now I am checking whether the capital B is a pipeline. No. Then the capital B is a null. No. Again increment the j. Now what is my j value? 5. So what is there in the 1 5? 1,5 is the pipeline. So when I'll come to this one, 1,5 it is not equal to pipeline, but 1,5 is equal to pipeline. So this condition will become false. So I'll come out of this for loop and j will be an incremented by 1. Now what is my j value? Previously it was 5, now it is 6. So when I'll come to this one, now I'll again go to the while loop. Now I am checking that whether 1,6 is not equal to the null. So what is my 1,6? 1,6 is a at symbol, that is epsilon. So that means this condition is true. 1,6 is not equal to the null. So yes, it is true because it is an epsilon symbol. Again I'll enter into this one. Again I'll check it is a not of the non-terminal. Yes, it is a terminal. Therefore again I'll enter into this one. Then first of the 1, 1. Count is already incremented, no? So 1, 1. So I'll print that first of the 1, 1 is equal to an at symbol. Then again I'll print that at symbol. So at symbol we are printing. Count will be an incremented by 1. Now count will become 2. Again I'll come to this one. So already I have printed the at symbol. So now over both all are printed now. First of B is printed here. Then B is printed here. And epsilon is printed here. Only the left out thing I need to print is the close parenthesis. Okay. So before that one we will come to this for loop. So it is 1, 3. What is your j value? 6. Okay. So is your j, what is your 1,6 you are having? What is your 1,6 you are having? It is epsilon. Is epsilon is not equal to the null? Yes. This is also true. Again I'll increment the value of the j. So j will become a 7. Again when I'll come, this will become an false because 1, 7 is a epsilon. You can check this. 1, 7 will be an epsilon. So this condition will become false. Now j will be incremented to the 8. The j will increment to an 8 now. So again when I'll increment to the 8, again I'll go back to the while condition. But this condition will become false. So I'll come out of that one and I'll print the close parenthesis. So closing parenthesis will be an printed over here. Closing parenthesis will be an printed over here. So now after that one where we are, we will go back to the for loop and I value will be incremented. Now I value is 2. Is 2 is less than 2? No, this condition false. So we will come out of this first function. So this is how the first function will work. So what we are doing in this first function, we are computing the first of the A and first of the B. So first of the A is small letter A and first of the B is nothing but the small b and the 8. So here we are printing that one. A, here we are printing for first of A and we are printing B and the 8 for the first of the B. So this is a tracing for your first function. I think all of you have understood this first function. So next I will move on to the follow function.